me and Percy here are going to be talking to y'all today about the cardiovascular system. And I'm going to go ahead and do a screen share, and we will get started. The first slide I'll share with y'all is this is the video that I posted for everyone that I wanted y'all to watch. It's of course Hank talking about the the cardiovascular system, and it gives a really quick, because he talks fast, rundown, but it's really an excellent video as far as refresher going back and looking through things. I'm going to go ahead and full screen our PowerPoint. All right, so make sure you watch this video. All right, so basic things about the heart. So if you're new to the class, there's a lot of stuff on these PowerPoints, but I'll always tell you when you're watching them, this is something you should write down, or this is a note that you're going to need to know. So little kind of facts, not necessarily things that you have to write down, but our heart beats from the time we are born, actually from at 4.5 weeks to the time we die, 4.5 weeks gestation to the time we die. The cardiovascular system contains not only the heart, but the blood vessels and the blood. So we're going to be talking about the whole cardiovascular system. Our heart moves blood, and that's what its job is, because when it's moving the blood, it's also supplying oxygen to all of our cells to keep us alive, and we're going to get into that too. The heart has 4 chambers. This sounds like a SurveyMonkey question, and it's a muscle. And it's a muscle unlike any other muscle that we have in our body, because it is its own type of muscular cell. So the only place you'll find that is the heart. And it's strong, and because it has to be. It never stops working, right? Or at least we hope so. And a lot of people think that the heart's over here, but it's actually mediastinum right here in the center, just slightly to the left, right about where Percy's paw is. The adult heart is about the size of your fist. So usually you're able to get a good average by looking at your own fist. And the heart contains 3 linings. This you do want to write down, and you do want to know. The linings of the heart are the pericardium, the myocardium, and the endocardium. The pericardium is the outermost lining, okay? The myo meaning muscle, is the muscular layer of the heart. And it's kind of like the thickest, and it's because it's got a big job to do. And then the endocardium is the innermost, real thin, and it lays almost right up against the heart, and it has the electrical conductive system that runs partially through it. And we'll talk about that later. So make sure you know the 3 linings: the pericardium, the myocardium, and the endocardium. And here's a picture of a heart. Here's human's heart, autopsied. It was very healthy. And you can see it's red. It looks like a nice, healthy heart. And then here is a heart with cardiovascular disease, arteriosclerosis, and numerous other conditions. It doesn't even look like a heart. You can see the fat and the plaque and everything around it. So we need to take care of our heart. We need to keep it a nice, lean, red muscle, not a fatty, enlarged tissue. All right? Most of the heart is cardiac muscle, and we have connections with not only all parts of the body, but the nervous system, the brain, and sometimes we don't think about that. We don't think about, oh, hey, I need to make my heart beat. Fortunately, because it's part of the autonomic nervous system, all right? And so that means that we're not responsible for it. Our body just naturally does it. Okay? The left and the right sides of the heart are separated by the septum. So that's a term that you need to know. And the septum's straight down the middle. The right side of the heart moves blood from the body to the lungs. And the left side pumps blood back to the body. It's a lot more detailed than that, and we're going to go into that, okay? There are, like I said, 4 chambers of the heart, and the first thing you have to know, and make sure you write this down, is whenever you see a picture like this, and you're looking at the heart, this is always patient's right, patient's left, not your right or left. Because if I hold up my left hand, it's on the right side, okay? So the first thing you'll do whenever you are looking at a patient to hook up an EKG or going to take a quiz is look at, when you have that sheet of paper in front of you, I always tell my students to put a big R and circle it for right and an L for left, so you don't get confused. And when you're with your patients, even if you sometimes have to face the direction they're facing, so if they're looking this way, you look this way, so your right is their right and their left is your left. So never, always you want to make sure that you don't confuse those, because you don't want to hook up leads wrong for like a 12 lead EKG or something like that, okay? So we're going to start talking first about the right chamber. So the right chamber of our heart is, the first one is the right atrium. It's the smaller of the chambers, and then it leads to the right ventricle. And the left chambers are the left atrium and the left ventricle. And we notice here that this left ventricle is really big, so take notice of that. And it has extra muscle on around it, and I'll explain why, okay? So the atrium are the top, you need to know, and the ventricles are the bottom. All right, the atria receives blood that comes into the heart, and then this is good if you need to go back and write down how the process goes. But instead of reading it to you, because you can read it, I kind of like to explain it. So I like to have my picture, and so we're going to follow the cursor around. So what we're looking at here is like a cross section of the heart. So we have anything that's below, we call that inferior, and if something's above, we call that superior, right? So we're having the, and usually in anatomical pictures, blue is going to stand for something that is deoxygenated, something that is a vein, okay? That's a SurveyMonkey question, okay? And red is going to serve as something that is oxygenated, and we call them, those are our arteries, okay? So what we're looking at here is the superior vena cava, or superior vein, and then this is the inferior vena cava. And then when we're looking here, this is called the aortic arch, and then it leads back down and it goes to the aorta, and it's an artery. It's the largest artery in the body, okay? And that's what this previous slide was stating, and how everything is set up. So what happens is, we're going to assume that we've already done one cycle. So let's talk about how the blood comes back in. So it's gone through our body. Our body has used all of the oxygen from the blood cells, and now it's sending the cells back to the heart so that the heart can send those cells to the lungs, and oxygen exchange can occur, and then it brings it back to the heart and then sends it back out to the body. And it's a continuous cycle. And we need to know that cycle. That cycle is important, okay? When we talk, let me see what my next picture is. No, it's not. So when we talk about how the heart's set up, the right atria here is what receives either from the superior or inferior. Both of them dump all of the deoxygenated blood that's been used up and into the right atrium. So it's the first place that all the used blood comes. And then it's moved through a valve, we'll talk about it in a minute, and it's moved to the right ventricle. From there, it's moved through another valve that you can't really see. And that valve takes, and you can't tell by this picture, but it takes it and sends it to the lungs. And in the lungs, we're also going to learn about respiratory system, but in the lungs, oxygen exchange happens, because when you breathe in, right, you're breathing in O2 and you're exhaling CO2, right? So our blood vessels, when they enter into the lungs, are dumping off all of the bad CO2, and the lungs are exchanging it for brand new O2. And so now the blood vessels are pumped up, they've got full of oxygen, and they're ready to go. So they enter in right through here into the left atrium, and they're oxygenated, okay? Because they've been to the lungs. And from there they move down through a valve, and the blood is sent to this big left ventricle. Why is the left ventricle so big? It's big because it gives us the massive force to send the blood into the directions that it needs to go. Sorry. It's either going to go through the aortic arch and down to the limbs, like the lower body, through the aorta, or it's going to go up and then it's going to go branching off and go through and up to our neck and the arms and the head. And we'll talk about the different parts of that in just a few. So anytime when it's leaving full of oxygenated blood. And that's what all of this is saying. Remember, you can pause if you like to take extra notes. Okay, the next part is we're talking about the valves. This is one of your questions for SurveyMonkey 2. It's kind of interesting. So you watch this get all your answers. So your valves, I hope my lights are flipping, I hope I don't go out. You have multiple valves in the heart, and what they basically do is they can open and close and seal. And what that does is it prevents blood from moving back up into the previous chamber. So we want it to continue to flow. So it's like a pressure force, all right? And these valves are important because if they're not working properly, if they have a leak or if they're weak, then that can cause heart issues, okay? We'll talk about that later when we talk about cardiovascular diseases, okay? And remember, when the blood comes in to the right atrium, it's deoxygenated, and its job is to be sent through into the lungs to become oxygenated. So let's talk about the valves. Now, this picture is kind of difficult to fully understand because of the way we're looking at it. So I always like to show another view, okay? And this picture's a little bit better here. So, and don't worry, you can go back and you can look at the different valves that we're going to be talking about here. So our first valve, and that's what this is supposed to represent, is the tricuspid. And it's tri because that means three, because there's three flaps that open and close to form that seal. So when the blood is pushed from the right atrium down into the right ventricle, what you're able to do is this valve closes off, and then it's going to move. Hi. And from here, it's going to move, and it's going to go towards the lung. And you'll notice here, going back to this picture, that you see something called the pulmonary valve. This is also called this, you might hear it referred to as semilunar. Okay, but the pulmonary valve, oops, did I pass it? No. The pulmonary valve is somewhere right in here, and it's the valve that opens for the lungs. And so when it comes back into the heart, into the left atrium, it stays, and then this valve opens, like this picture. This valve is called the bicuspid, but you might also hear it referred to as the mitral, because there's two different terms for the same valve. So it's mitral or bicuspid. And then as it exits and leaves, that's where we can go back up here, it leaves through the aortic valve. So those are the valves. So if we're looking, the tricuspid is the first on the right side, and then there's the pulmonary, and then it comes back into the left atrium and then goes through the mitral valve. This is an example, like if we were looking through the top of somebody's head all the way down and straight into them, this is what we'd be looking at. So we'll talk about the valves more, don't worry. And I'm going to go ahead and make this full size again. And this right here is just going back over what we were talking about: pulmonary vein, talking about the left atrium and the right atrium, and then the valves and how the blood flows. And I had mentioned this earlier, but another important fact is that the aorta is the largest artery in the body. They love always asking me that question on test. This video here is something that I'm going to also post in the teens, so you'll want to make sure. And it just talks about the flow. But from the aorta, the blood begins a journey. And that's what I was mentioning. It journeys all the way through every part of our body. And the arteries carry all of the oxygen-rich blood to our fingertips and to our brain and to our eyes, all the way down to our toes. And then once they have been oxygenated and the oxygen has been removed, they have to make their way back up. So you were like, well, everybody asks, well, how do veins and arteries connect? Well, they connect through this little bridge, and that bridge is called a capillary. All right, that's also a Survey Monkey question. So the capillaries act as bridges. So when your blood is now deoxygenated, it'll flow through an area, it's a capillary, and it'll move on to the vein. And from the veins, we know veins carry deoxygenated blood, and they're going to carry all of that deoxygenated blood cells back up or down to the heart, so that the heart can start the process all over again of sending the deoxygenated blood cells to the lungs to become reoxygenated, and then do the cycle all over again. And I will post this video. I will also post this video. If everything that I was saying is confusing, this video right here is amazing. It explains everything with not only pictures, but in a really fluid, easy to understand way. So I definitely recommend watching this one. All right, we're going to move and talk about the vascular system of the heart. And if you look, what we're looking at is this is what supplies the blood to the heart itself, because the heart has its very own vascular system. And this is where things get a little tiny bit complicated, okay? Because didn't I just tell you that the veins are always deoxygenated and the arteries are always oxygenated? Well, this is one of the few times when we're talking about this coronary artery and the different, depending on what cycle and where it's at, it possibly might be carrying deoxygenated blood. And that's because of what cycle is it going through as it is nourishing the heart. All right? And that's what it's talking about here. It's important that all of these vessels stay open, and we'll talk about that with the diseases, because if one of them gets clogged or one of them gets blocked, that all that tissue from there under is going to die, and you're going to have ischemia, which is a heart attack or death. So this is why we prevent that from happening, and we'll talk about ways to keep our heart healthy. Okay? And this is what I was talking about. This is a term that you need to write down, make sure you know. Occlusion. Occlusion means it's blocked. Okay? So make sure you know that. And when we talk about the heart, we speak of occlusions. We say that it's, 25% occluded or 10% occluded or so forth. And whenever anything is occluded, no matter what the percentage is, that's bad, because that means that there is not oxygenated blood getting to the tissue and the muscle. So when that happens, when there is a lack of blood, this is what we need to know. It's this term right here. ischemia. Ischemia is the lack of blood flow to the heart. Okay, so make sure you know that term. And the next term is infarction. And this is why sometimes you'll hear a heart attack referred to as an MI, because what that stands for is so the muscle myocardium infarction. So that means basically death of the heart, or death of the tissue of the heart. So, so infarction is death, and then we know the myocardium is the muscle layer. So that's why you might see, say, a patient or a doctor or a nurse will say the patient had an MI, and that's what that stands for. But an MI is the same thing as a heart attack, okay? When cardiac arrest occurs, it's a little different than an MI or heart attack. Cardiac arrest is when the heart is no longer pumping or beating. It is not moving blood, okay? Cardiac arrest can be caused by trauma, medical conditions, old age. There's many reasons, and we'll talk about that. And then if all of this occurs, what's going to happen to the tissue in our brain and in our feet and our hands? It's going to lack oxygen, and it's going to become hypoxic. So that's a term you need to know. When the tissue in your body lacks oxygen, that is hypoxia, okay? And we don't want hypoxia. Hypoxia is bad. We want to keep all of our tissue oxygenated. This picture here is a nice picture because it's showing you what happens when, this is the close-up of this, but right here we have an occlusion, and it shows you right here there's blockage, and this is plaque and fat that's built up in this person's artery. So now the blood really can't squeeze through, and it's backing up, right? So what ends up happening is, you notice here that all of this area turns dark and it begins to die, and that's ischemia. All right, the heart tissue is dying. And we're going to stop because we're not going to go to conduction system today, and then I will pick up, but this